Yo, what is up, guys? Today I am working on another project. Okay, so this project is basically an artificial intelligence photo identifier. So if you've ever used Google image search, if you've ever wondered how like Google is able to tell what photo you put into Google image search, this is how. And I am basically going to build a neural network that uses a databases of different photos, and it's basically going to be able to predict what a photo I show it is based on the data it has on like previous photos. We're just gonna look at the code real quick before we run it. So first, I had to import the important stuff, which is like the TensorFlow, Matplotlib, the NumPy, and all of that. Then next, I had to load the CIFAR10, which is like basically like a compilation of like labeled datas. Someone somewhere labeled like already labeled like a bunch of photos of animals and planes and all of that and compiled them. So that's basically like loading that data set, loading the um images to this neural network. And so yeah, it's then next is normalize the values between 0 and 1. So this is basically testing like a couple of images based on another search a certain amount of images. So it's basically like just like testing to see which ones are like as accurate to each other as possible, or basically yeah, like just to see which one looks closer to each other. So next, I asked it to display like 5 images from the training set. So it's gonna show either a plane, a horse, a ship, or a truck, but 5 images. Then what next? What it's gonna then next? I built the model. So that's the actual neural network. I built the model. I compiled it. I used an Atom for the optimizer, and yeah, metrics accuracy. So I want to test how accurate the model is and the data is, and then I trained the model. So I basically I used 3 epochs, which means I'm testing it 3 times, which is not a lot. So that's not gonna give me the best accuracy. I don't know if it is, but we'll see. Next, I evaluated the model and to test like the accuracy to see if the model is accurate. And yeah, so yeah, I also get the prediction. I test the model with 5 other pictures, then get the predictions of those pictures. So I have like 5 separate photos that, or the data set has 5 separate photos that it's gonna use to to determine how accurate the model is. And also, what I'm gonna do is that I am gonna then the last thing I do is I am gonna bring up an actual picture, which is I believe this is the picture here. Wait, let me look for the picture. It's the picture of a ship, I believe. So you can probably not see it because it's like a little bit, but let's just search it. It should be on Google somewhere. Tall ship. So yeah, like if it's search tall ship, I believe this is the actual photo, but I had to resize it because um the model can only accept 32 by 32 pixels for its for to for its labeling or whatever to for its data. But yeah, so I basically asked it to look for this image, which I downloaded and I resized and downloaded to my computer, and I asked it to look for that image and determine what image that is. Now you can probably tell that that is the photo of a ship, and it should be able to accurately predict that that is a ship if we did everything correct. I hope. So as you can see, the first thing it did was it brought up 5 photos. So these are like the testing photos or like the benchmark. So this is a frog, this is a truck, this is a truck, this is a there, that's an automobile. So it's gonna test its data sets or its data across all these photos to see which one best represents it. So it's basically training itself right now. What's doing? So it has over 1,563 photos, and what it's doing is that it's training itself based on those photos. It's going through those photos and it's like, oh, how accurate can we m- place those photos between these 5 sets, right? And lucky there should be more than 5 sets, cause it's yeah, cause truck is even made labeled twice, but it's whatever. But yeah, this normally takes a little bit of while, so we're just gonna chill while it happens. Or you know what? I'm gonna go do 50 push-ups, and by the time I'm done, it should be over. Alright, I'll try to count. That was definitely not 50 push-ups, but close enough. But yeah, it's still running, and yeah, it's still running. It's still running. It's still running. It's still running. La 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 la. Alright, let's check on X while we wait for the algorithm to run its course. Oh, goodness. Wow. Trump really chose the worst of the worst for his cabinet, man. Alright, we're almost there. Alright, let's see. And as you can see, it did predict that it was a ship. So there you have it, guys. The AI model I've built, it has been able to accurately predict that the photo that I downloaded um from the internet and put it into the um the the neural network it basically accurately predicted that it was a ship. So yeah, as you can also see, this is the things it also predicted. It was shown a photo of a frog, and it predicted that it was an actual frog. It was shown a photo of an airplane. It predicted that it was an actual airplane. Now it was shown a photo of a ship, and it predicted that it was an automobile, which is wrong. So that means the model itself is not completely 100% accurate. But it also look, it got showed a ship, it predicted a ship. It got showed a cat, it predicted a cat. So now we can look at the training accuracy and validation accuracy, and this is pretty good. So current, oh, not well, not good, but it's not bad because you can see the test accuracy. So currently, as of right now, the accuracy of this model is at 64% because I've only ran it like 3 times. So if I probably run it like 10 more times or 20 more times, the accuracy right here should increase to 20%, sorry, to 90 something percent or so. But yeah, guys, that's it for the video. If you liked the video, please like and subscribe. And if you didn't like the video, please also like and subscribe. And I'll see you guys in the next video. One love.